Welcome to Beyond the Prompt, the AI podcast based on discussions of the Large Language Model Reading Group of the Leiden Institute of Advanced Computer Science.
Today, we're delving into an exciting new paper, DeepSeek R1, Incentivizing Reasoning Capability in LLMs via Reinforcement Learning. This research explores how reinforcement learning, without any supervised fine-tuning, can significantly enhance reasoning capabilities in large language models. We'll break it down, discuss its impact, and share insights from the LLM reading group at LIAC's Leiden University. Artificial intelligence has always learned by example, but what if machines could develop reasoning skills just like humans do, through trial and error? DeepSeek R1 suggests this might not just be possible, but could revolutionize how AI thinks.
This is a fascinating study because it challenges some traditional assumptions about how we train AI models to reason. Typically, we rely on supervised fine-tuning, feeding the model vast amounts of labeled data to improve its performance. But the researchers behind DeepSeek R1 took a different approach. Instead, they allowed the model to improve itself purely through reinforcement learning, by setting up a reward system that encouraged better reasoning.
Let's start with a simple analogy. Imagine you're learning how to solve a puzzle. If someone hands you the completed puzzle and asks you to memorize the solution, you might recall it later, but that doesn't mean you truly understand how to solve it. That's what supervised learning does. It gives models the answers. Reinforcement learning, on the other hand, is like trying to solve the puzzle yourself. You make mistakes, you learn from feedback, and gradually you develop a real, adaptable problem-solving ability.
Exactly. The researchers started with DeepSeek R10, a model trained entirely through reinforcement learning. No human-labeled data, just trial and error. And what's really fascinating is that over time, the model started showing signs of reasoning, building logical chains of thought, and even realizing when it made mistakes, kind of like when a person has an aha moment. Plus, if you look at the convergence graphs, you'll notice something interesting. The model's answers and thought processes keep getting longer. That suggests that breaking a problem into smaller steps makes it more likely to reach the right answer, just like how we solve complex problems step by step.
However, while DeepSeek R10 was impressive, it wasn't perfect. Its responses were sometimes hard to read, and it had a tendency to mix languages in an unpredictable way. To address these issues, the team introduced DeepSeek R1, a refined version that incorporated multi-stage training and cold start data before reinforcement learning. This hybrid approach helped the model maintain its reasoning strengths while improving its clarity and usability.
Our reading group had a lively discussion about this paper. One of the first points of debate was the cost-effectiveness of reinforcement learning compared to supervised fine-tuning. The paper suggests that RL is a cheaper alternative, but several members questioned whether that claim holds up in practice.
Right. The hype suggested that this method is resource efficient, but it still relies on an extremely large base model, DeepSeek V3, which had to be pre-trained at a significant cost. Some of our members noted that while the reinforcement learning stage might be cheaper than supervised fine-tuning, it wouldn't be viable without an already robust base model.
Another key topic was knowledge distillation. The authors demonstrated that you can take a powerful, reasoning-heavy model and transfer its abilities to smaller models, making them more efficient while retaining strong reasoning performance. This opens doors to making sophisticated AI more accessible.
But there's an open question here. How well does knowledge distillation actually work? Some in our group were skeptical. Can a small model truly capture the deep reasoning strategies of a much larger one? Or is it merely mimicking surface-level patterns? More research is needed to understand the long-term trade-offs.
No paper is without its challenges, and DeepSeek R1 has its share. One major issue is readability. The initial reinforcement learning model produced responses that were technically correct but difficult to interpret. That's why the researchers had to introduce structured fine-tuning.
Then there's inference cost. Even if RL is cheaper during training, inference, actually running the model, can be expensive. Longer reasoning chains mean longer processing times, and that directly translates to higher computational costs. In practical applications, This could limit how widely these models can be deployed.
And of course, we have ethics. Reinforcement learning allows AI to develop its own reasoning heuristics, but what happens if those heuristics reinforce biases? Without transparency into how these reasoning behaviors emerge, there's a risk of unpredictable or even harmful outputs.
That's especially relevant when comparing this model to OpenAI's offerings. OpenAI applies strict alignment measures to ensure their models follow ethical guidelines, whereas DeepSeek R1 appears to have fewer constraints. That could make it more useful for researchers but riskier for deployment in real-world applications.
So, what's next? One promising direction is testing reinforcement learning on smaller or more diverse base models. If this technique can work with various architectures, it could truly democratize access to high-quality AI reasoning.
Another avenue is improving reward functions. Right now, the model is rewarded mostly for getting the final answer right. But what if we designed rewards to encourage clearer reasoning steps? That could improve interpretability and make AI's decision-making process more transparent.
And let's not forget generalization. One of the biggest challenges for any AI model is handling novel problems. How well do RL-trained models perform when faced with entirely new kinds of reasoning tasks, even including words they have never seen? There's still much to explore.
Well, that's all the time we have for today. If you're curious about this paper or want to read and hear more from our LLM reading group, check out the other episodes.
Thanks for tuning in to Beyond the Prompt. Until next time, keep questioning, keep learning, and stay curious.